Hello everyone! In this video, I would like to explain how I created a slope heat map automation tool for solar PV project design. The main purpose of this tool is to understand the existing ground slope condition before placing the racking system or tracker layout. For any solar PV project, terrain slope is very important. If the ground slope is high, it can impact tracker placement, grading quantity, access road design, construction feasibility, and overall project cost. Normally, we use Civil 3D or other design software to review the terrain. But for the early design stage, we need a faster and easier method to understand the slope condition. That is why I developed this Python-based Slope Heatmap tool. In this workflow, I am using two input files. The first input is a GeoTIFF file. This GeoTIFF contains the existing ground elevation data. The second input is a DXF boundary file. This boundary defines the project area where we need to create the slope heat map. The tool reads the DXF boundary and clips the GeoTIFF only inside the project boundary. If there are internal exclusion areas or holes inside the boundary, the tool can remove those areas from the heat map. After clipping the GeoTIFF, the tool calculates the slope from the elevation data. The slope is calculated based on the elevation difference in both x direction and y direction. Then the slope percentage is created for each raster cell. Once the slope is calculated, the tool classifies the slope into different ranges. For example, 0 to 10%, 10 to 11%, 11 to 12%, 12 to 13%, 13 to 14%, 14 to 15%, and above 15%. This means we can know how many acres are within 0 to 10% slope, how many acres are within 10 to 12% slope, and how many acres are above 15% slope. This helps us make design decisions based on actual numbers, not only based on visual colors. After the slope classification is complete, the tool creates three main outputs. The first output is a PNG heat map. The second output is a DXF file. This DXF file can be opened in CAD software, and the heat map image is placed in the correct project coordinate location. The third output is a KMZ file. This KMZ file can be opened directly in Google Earth. This is very useful for sharing the slope heat map with team members who may not have Civil 3D or GIS software. One of the main advantages of this tool is that we can review the existing ground slope without using Civil 3D. Using only the GeoTIFF and DXF boundary, we can create a slope heat map, slope area summary, CAD output, and Google Earth KMZ output. This helps during early-stage solar design, racking system selection, grading review, and constructability analysis. In summary, this tool helps us understand the terrain condition faster. It supports better racking placement decisions. It helps reduce unnecessary grading. It also helps the design team identify difficult terrain areas at the beginning of the project. This is how I am using Python automation to improve solar PV grading and terrain analysis workflows. Thank you for watching.